Good afternoon, and welcome to this afternoon session where we'll talk about how HP's three-part products are using virtual volumes to gain extra insight into the storage. The usual legal disclaimer, everything we say on stage may or may not actually ever see it in a product. So my name is Patrick Dirks. I am the manager of the virtual volumes team at VMware, and I'm here with Ivan Iacone from HP, who will be talking about the HP specifics of what they do in a minute. But first, I thought I might give you an overview of what virtual volumes are and how they work to kind of set the stage a little bit. You'll hear a lot this week about the software-defined data center and how the flexibility from using software to control your data center gives you the agility to meet the changing demands that your data centers are going to need. And in today's talk, we're going to focus very specifically on the storage part of that story. So the challenges we see in storage and storage management today is basically that it's happening at the wrong level. That as you think as a vSphere administrator about virtual disks and virtual machines, nowhere do LUNs come up. LUNs only exist because they're a convenient abstraction for the hardware. And so it forces you to create these large, uniform in characteristics, storage chunks, interact with storage admins to get them created on demand as needed, reconfigure them as needed. And it forces you to do a lot of bookkeeping in spreadsheets or in scripts and things like that to make up for the fact that the granularity really is just wrong. And it forces you to pre-partition all the space you have into these fixed-size chunks that may or may not be the right size. And you have some space set aside that's replicated, and some space set aside that's deduplicated, and some space set aside that's compressed. And if you have the wrong mix, it may be very complicated to change that. So we can do better. And I mean VMware, because we think that the hypervisor is ideally positioned to mediate between the needs of the virtual machines and the capabilities of the storage that underlies it. We are in the data path. All the I/O goes through the hypervisor, so we see everything. And we have the perfect view up into the VM, and we know about the VM's requirements and what the VM is experiencing. In fact, we create what the VM is experiencing. And with virtual volumes, we now also get insight into the capabilities of the hardware and the overall global infrastructure of the storage underneath. So we know what's congested, we know what's not congested, we know when policies are being violated, we can move things around as needed. The hypervisor is a great place to inject a new level of abstraction. So as we talk about software-defined storage, you'll see us referring to policy-driven control plane. That is the central innovation. Because instead of relying on scripts that know which VMs live on which data stores and can automatically move things around as needed, which is a very brittle automation mechanism, using policies to control the automation injects actual knowledge into the system and lets the system respond based on the policies that you've previously expressed. And those policies drive a virtual data plane that offers at the top layer a uniform set of services that are available regardless of whether they're presented by the hardware or possibly presented by I/O filters that are injected on demand. So you see data protection, a uniform notion of mobility, performance, and all of that is built on virtual data stores that we segregate into three categories: the sort of hyper-converged on-server infrastructure, the cloud storage infrastructure, and what we'll be focusing on today, the SAN NAS infrastructure. So at its lowest level, the software-defined storage pools all the storage in your data system, in your data center. And this is all the storage. This is not just one LUN, this is not just one array. Everything is presented uniformly. And the capabilities of the hardware are expressed in ways that we'll see in a minute, so that the policy-driven control engine knows what can be placed where. So these data services can be applied uniformly to all the objects in your VM. And as I said, everything is driven by this policy control engine. So let's zoom in on the traditional SAN NAS storage. The architecture of virtual volumes introduces one central new player, and that's the VASA provider. So the array that is currently existing is augmented with a VASA provider, and that VASA provider communicates with vSphere on behalf of the array, sort of an agent for the array. It expresses the capabilities of the array, and it handles the management path, as we'll see in a second. So there's no more file systems. There's no more LUNs in the storage side that vSphere then builds a file system on top of, which completely masks all knowledge of which virtual machines live where on the data store. And instead, the objects that virtual machines need are created directly through this augmented VASA protocol to the VASA provider that's provided by the storage vendor. So the VASA provider is intimately tied to the array and knows how to create objects on the array and knows how to talk to vSphere and advertise to vSphere the capabilities of the underlying storage. So that's what's used to create the VVols, and it's an out-of-band path in a new mechanism. The space on an array is partitioned into any number of storage containers or virtual data stores. And the key difference here from what you may know as regular run-of-the-mill storage virtualization is that this pool is not just one large pool of all of the drives in the system or something like that, but it's more like a quota or an entitlement. It's all the capabilities and all the storage that can be offered. And it's the presence of those capabilities that makes it so that if you have 5 terabytes worth of drives attached to your array or something, they can be used on the fly to back either straight virtual disks or virtual disks that have some data services applied or virtual disks that have replication applied to them without pre-partitioning everything up. So you get all the storage and all the capabilities, and the array is in charge of matching up the two. So virtual volumes bring a direct awareness at the array level of the virtual disks of a virtual machine. And in fact, there's attributes on it that let the storage get more insight into that. So now, what previously was an anonymous collection of blocks exported by the array in the form of a LUN that VMFS scattered the blocks of your virtual disks on, now is completely visible as first-class citizens on the array in the form of virtual volumes. And that frees the array to apply all kinds of new capabilities to it. The most obvious one is snapshots and clones, but the array, through the capabilities that it can advertise, can offer any service, and the profiles that the vSphere administrator writes and associates with the virtual disk and VMs can require any of those. And it's that policy layer in the policy layer in vSphere that matches up those two, that finds compatible storage for a given VM, given the profile that's expressed, and given what the capabilities are expressed by the data store. And we do all of that out of band, but what we retain in band is the data path that exists today. So if you have a fiber channel array, you'll be using fiber channel to talk SCSI to the array and do all the data transfers that way. So in the case of SCSI, that protocol endpoint is expressed as a sort of a management LUN. It's not actually it doesn't actually have any data blocks associated with it. It's not a data LUN, nothing is allocated on it, but that's just the addressing point for the storage. And the secondary LUN ID is used to differentiate the specific PE. And if the array happens to be a NAS array, that's a mount point, and files inside there are used to refer to individual volumes. So the data path is essentially unchanged with all of this. And so the array using the VP presents everything it's capable of as sort of a menu for the profiles to choose from. And the vSphere administrator writes profiles and policies that are applied to the VMs that have to be met by the underlying storage. And that's how they're met, and that's how they're maintained in compliance. So that lets us move from a world where the storage exports merely large ranges of blocks with certain uniform capabilities without any awareness of what they are or what they represent, to a world where the virtual disks of a VM are directly represented and directly accessible and can be directly operated on by the array itself through policies at the right granularity and without forcing you to do LUN management. And with that, I'd like to bring up Ivan Yannicone from HP to give you some of the specifics.
Hey, thank you, Patrick. You hear me? Yeah. That's great. Hey, cheers.
There you go. Thanks.
So this is great. How many FreePAR customers do we have in the room? Okay, so half. So that means that it's half of potential FreePAR customers. So that's great. So what I'm going to do, I'm going to give you an overview of why FreePAR is so good with VMware today and what we are doing to continue to be so great in the future. And I've also brought a customer with me, Dan Johns from Allianz, and he's going to show you how VVols is going to help their environment. So first of all, let's start looking at when we started this adventure with VMware. We actually started talking to VMware when we were still an independent company, when FreePAR still wasn't acquired by HP. And then we did a first preview in VMworld 2011. So that was, what, 3 years ago. In May 2012, FreePAR was selected to be the fiber channel reference platform for VVols. So all the testing that VMware is doing on VVols, on fiber channel, is done on the HP FreePAR StoreServ platform. In October 2012, we did a blog. Calvin, that is here with us, he did a great blog where he was showcasing some of the capabilities of how we were working. And then we started in June 2014, the first beta. And that's where I'm taking in the customer that is participating on that beta. And of course, when the product is ready, when the VMware release is ready, we're going to be there day one, and we're going to be part of the HCL and so on. So let's take a look at what is so interesting about the FreePAR array and the FreePAR architecture. So we've got a variety of platforms from the 7200 up to the 10,000. We've got an all-flash array that is a 7450. So if you're looking at a very competitive price, about $2 per gig for flash, the 7450 can offer that. We recently announced on Friday an all-flash array that is 35K. So a very, very interesting and competitive entry point. But of course, if you don't want to have an all-flash array, you want to have an hybrid solution or an all-HDD solution, we've got the right platform. And what is the most amazing thing about this architecture is that it doesn't depend how you enter. You can enter with a 2-node, and you can scale up to an 8-node if it's at a 10,000. You can enter with a 2-node and scale up to a 4-node if it's a 7400. And you can scale up and scale out as you like. And in fact, I've got a slide that actually talks about this a bit more in detail. So we've got scalability within the system. So that means that is the ability of the platform to be able to scale up and scale out. We've also got scalability across systems. So what does that mean? That means that you can have stretched clusters capabilities, and I'm going to cover that in the next slide, but also mean that you can migrate data online from one system to another. And we've also got systems within systems. So what is that? That is virtual storage arrays. So you can have one FreePAR system, and then you can logical partition it for secure multi-tenancy, or also for defined quality of service rules on those particular virtual storage arrays. Another interesting thing about our architecture is part of the 2 secret sources. Part of the secret source is the storage layer that I'm going to talk about right now, and the other interesting part is the hardware layer, the ASIC. So what we do is that we've got a first level of abstraction, that is the chunklet abstraction, that allows you to virtualize any kind of media. It can be HDDs, it can be SSDs, or it can be whatever media is going to come in the future. Then we take all of these different chunklets and we aggregate them in RAIDlets. And we do what we call system-wide striping. So this is extremely important when you look at big virtualized environments where they actually can make the most out of the system. And on top of that, we have a virtual volume abstraction. So this is a very important abstraction for us because that allows us to give a lot of very particular data services that can then be offered to the VVol layer. And on top of that, of course, we've got the exporter LUNs. So let me talk a bit more about the abstraction that we have at a virtual volume layer. At a virtual volume layer, we can apply things like quality of service rules. So you can have a certain virtual volume, and you can provision storage, capacity, and also storage performance. Also, at that layer of abstraction, you can have an augmentation of the cache. So you can define to give that particular volume more performance acceleration when it comes to random reads. And on top of that, we also got a technology that is called persistent ports that just provides an extra layer of virtualization and abstraction between the storage array and the hypervisor. And I'm going to explain this a bit more because this is very interesting when it comes to not depending anymore on the MPIO layer, when it comes to not depending anymore on the fabric. And this abstracts completely some of the failures, so the MPIO layer never kicks in. The hardware source, especially for those customers that are already FreePAR customers, is the ASIC. And the ASIC really allows us to offload a lot of operations from the CPU. What is important when it comes to some of the operations for VMware is all the VAI operations. So we've got the assisted block 0, we've got the assisted lock-in, the assisted full copy. All those operations are offloaded to the ASIC. So everything is done in line in real time. Another interesting functionality that we have is what we call peer persistence. That is basically our VMSC certified stretch cluster implementation. And what is quite interesting about this implementation is that it's appliance-free. So you don't need to have an external appliance. Everything is built in within the architecture. And of course, something that we're very famous for, and we've been working very closely with VMware for the past 5 years, is space reclamation. So the ability to reclaim space over time. And that space reclamation can happen because we're doing zero detect or because we're just doing an unmap operation. So let's take a look at what does it mean to start using VVols with FreePAR. So I've seen from the previous slides, we are talking about a very scalable and reliable architecture, but also an architecture that is offering a lot of different data services. So you really have the opportunity to provision the data services no longer on a per LUN basis, but you're able to do it on a per guest basis for every single guest that you are provisioning with VVols. So for example, we now are able to have storage quality of service on a per VM. So you can provision a virtual machine, and you can decide what is the maximum amount of IOPS that that particular guest can get, what is the minimum, and if it's a particular mission-critical application, you can also define a latency goal. When it comes to sub-tiering, the same thing. You don't have to do sub-tiering on the entire LUN anymore. You can actually decide, okay, these are only certain applications that I want to sub-tier. Caching and high availability with peer persistence. So this is really the great advantage of using VVol on a FreePAR architecture. You get great availability, resiliency, and tons of data services. Another interesting technology that we introduced in June of this year is the ability to do deduplication. We do deduplication in line, assisted by the ASIC, and we've got this cool capability that is called thin clones. So the thin clones technology today really relies on VAI to give host hints. So basically, we just get the control data, and we just copy the metadata in the background. The concept of VAI is not going to be there anymore once we introduce VVols, but we can still rely on the thin clone technology. So the moment you do a clone at a hypervisor layer, we will duplicate all the data on the fly. So you're not allocating any storage on the back end. I've already covered the quality of service, But I think this is another very extremely cool functionality and differentiator for us, because you basically have got full control on all your virtual machines. And then the ability to enable, that sub-tiering or that cache augmentation on a per VV basis is also very powerful, especially if you're in the storage provider business and so on. You can actually think about that being a service where you can back charge on a particular tenant. So this is just an insight of the CLI, and this is something that we've been actively working on. And what is very different here is that the moment you run this command, you can actually see what guests have been configured on that particular storage array. So you can see what is the guest OS. You can see if the state is bound or unbound. So is that virtual machine running, or is that virtual machine not running? And then you can also drill down and see exactly every single virtual machine, how many VVols it's using. And think about how powerful this is. This is powerful because all the data services that I mentioned earlier, you can apply at the guest level, or you can also apply at the virus VVols level. It's very powerful because when it comes to do capacity management, capacity planning, performance reporting, and so on, you can really drill down to the guest level and then to the virus VVols. And this is something that you were not really able to do earlier on. Usually, you just looked at the entire LUN, then you tried to do some troubleshooting at the hypervisor layer, but you didn't really have all the insight that you can have today with VVols. This is a sneak peek in the next generation management console that we're working on. So we are expecting that the majority of the users will want to use vSphere client, web client, if this is 100% VMware deployment. But there's a lot of cases where customers use our arrays as a shared infrastructure. So they're using it for VVol and other applications, or other hypervisors. So it's important to give customers the ability to have an element manager that is able to see exactly what is happening on a per VVol basis. So the idea is that we're going to treat these guests and these VVols as their normal volumes, and then we can just monitor them. We can do all the reporting and so on, and we can also give these properties at the dashboard level. So we can just make sure that every time there's a problem on certain VVols and so on, it just gets reflected on this dashboard. So the final question here is really, why FreePass StoreServ with VVols, right? So the first thing is that it's very simple. Patrick mentioned the VASA provider, and the way we implemented the VASA provider that is built in the cluster, in the node, and it's a one operation. So it's just a start command. So you don't have to install anything externally to the system. You don't have to manage something else. It's going to be built within the very reliable and redundant architecture of the node. Control, of course. As I mentioned earlier, you can put your data services on every single guest that we have. So you really have full control on your environment. And of course, efficient. Efficient because it can leverage all the thin technologies that we have today, thin provisioning, thin deduplication, the ability to do thousands of snapshots. And we actually got a very nice example from the customer that is here today. And of course, rock solid. The architecture is an architecture that is designed and capable of delivering 6 nines availability. We've been doing testing with VVol since 2009, and they're a reference platform. So when it comes to interoperability, when it comes to testing, we have really a rock-solid platform. So let me introduce you Daniel Jones, that is the Senior Storage Architect for Allianz, global investor. Allianz is an assessment management company with presence in over 20 countries, and they've been helping us doing some of the beta and some of the testing between FreePAR and VVols. They've been a good FreePAR customer for almost 8 years. They've got all the systems, the T classes, and now they've got the V classes in 2 data centers, and they replicate between the 2 data centers. So what is interesting about the environment is really how heavily they rely on the Think technologies, how heavily they rely on snapshots, and they get a lot of benefits out of this. If you just look at some of the graph here, we can see they've got around 1.3 petabyte of storage. The environment is around 80% virtualized, and they've got 600 virtual machines in production. And on every system, they have around 5,000 snapshots. 5,000 snapshots are a lot of snapshots because I think you keep, a week of snaps for every guest that you have, and then they replicate all these snapshots between data centers. And what is interesting is that all the snapshots on a 3-part array and a 3-part architecture are without reservations, so you don't have to reserve any space up front. So and out of this, they're getting huge savings. So if they had to use cloning, or if they had to reserve space for the snapshot, they would have had to purchase around 5.3 petabyte of physical storage. But they don't, because they're relying on all the good things that they're getting out of the 3-part architecture. So why don't you tell me a bit about your experience with 3-part?
Well, our environment isn't really particularly large. I've heard about people with 10,000 VMs, and so ours is really small that way. But our business demands high performance and high availability, and we are doing very well at that. We have very little downtime, and we have very good performance. You were mentioning
Sure, yeah.
1 millisecond.
So this
latency.
is just to show you guys. This is just a graph of the host latency that they're getting out of their arrays. So they're getting around 2 milliseconds. And what about when it comes to manageability? How it comes to managing the arrays and so on?
Oh yeah, so I've been working on 3-part arrays for about 7 years, and and when we stood up our first pair, I was given the concepts guide and the admin guide, and within a day or so, I was running, making volumes and exporting to hosts and getting it going.
Okay.
So a beginning admin can do that with the GUI interface, and an experienced somebody experienced on the system can create hundreds of volumes in just a couple of hours, which we've done standing up our DR environment.
Okay, that's great. So, what's your feedback on VVols? I know that you guys were extremely interested in this new paradigm, that it would help you out on some of the challenges that you had in your environment. Can you please, maybe for the audience, so they can also understand how they can, they can benefit from this new technology? Yeah.
So when I first heard about it, I was really excited because because of the way we snapshot with application consistent snapshots that our SQL DBAs control, and we replicate to our DR site. Because of the way we're doing that, we have an awful lot of raw device mappings. And mostly that's okay, but there's definitely a lot of overhead involved in maintaining those, and there's some functionality issues there as well. Okay,
so if I remember from our conversations, you're saying that the fact that you don't have the data store anymore is a big positive. The fact that you're going to offload all the snapshotting and cloning directly to the array was another big positive.
Right. Yeah, the performance of our snapshots from the array side is fantastic, and we're able to replicate those snapshots and commit those to the volumes on the secondary side and keep a consistent copy, and then create snapshots on the second side for backup to our backups, basically.
And what do you think about manageability? Do you think that will change, between managing the data store and managing the new VVols paradigm?
Right. Well, the vSphere administrators will be the ones that get to do a lot of the lifecycle administration for VMs. So it'll free up storage admins time that we're right now creating various pieces of storage one-offs for these RDMs. So it'll free that up for,
okay.
make it for the
that's great, Dan. Thank you so much for your experience and sharing it.
Thank you, everybody.
Thank you, Dan. So I think it's never easy to speak to such a big audience, especially when you're used to it. So I appreciate him taking the time. I think it was important for us to show you an example of a real customer and a real deployment and how they're actually trying and testing VVols today. And just I would like to, to summarize a few things here. So we've been working extremely closely with VMware. I think I've made this pretty clear from all the investment that we had, also the investment that we've taken with some customers to actually try this technology. We really believe that this is a huge opportunity. The flexibility is going to benefit everybody. It's going to benefit storage admin, but also server admins. And I think the example that Dan made was quite interesting. And another point I would like to make is that I'm here talking on behalf of HP 3PAR StoreServ and HP Storage, but HP and VMware have got tight integration also when it comes to an end-to-end solution. So when it comes to compute, network, storage, we've got a great relationship with VMware. We've been talking to them and working closely with them for almost 12 years, and we've received a lot of recognition from customers, from the industry, and so on. And so this is also a very important thing to keep in mind as you look into your next deployment, and especially as you look into the VVols technology. With that said, I think we've got, almost on time. Time for some questions. Patrick, and of course, if there's some questions also for Dan, he will come up and answer them, but please feel free to come up, and I think perfect.
So does the VVols supported through both the NFS and fiber channel interfaces, or I guess from your platforms, both through NFS and block?
Please, there's... You got it. Yeah, it's on.
The VVols technology certainly supports both modes. It's supported on block storage arrays as well as NAS arrays. I can't speak to the specific capabilities of the 3PAR array.
It's fully block, right? We
go.
do block via fiber channel and iSCSI. I was mentioning fiber channel because that's where we're doing, closely the testing, but it's fully supported with iSCSI and FCE protocols.
Thank you.
Yeah, in fact, one of the nice things about virtual volumes is that with VVols, the distinction between block and NAS becomes much less important. The presence of the protocol endpoint is automatically determined and exported and configured, and you use VVols in exactly the same way on every data store, no matter whether it's NAS or block.
Could you use VVols for some instances where you have like an MSCS cluster, somebody like a SQL server has it on always on availability group? Because that's actually typically a shared RDM. Can that support that use case? I don't know.
I don't believe the current technology of VVols is suited for that because it is a shared RDM for exactly the reason that you want to send SCSI-3, I think persistent reservations they use, down to that RDM. And although VVols are the perfect replacement for RDMs because it becomes one-on-one with the storage, the presentation to the VM is still a regular virtual disk, and so it doesn't let you send the special commands that you would if you had an RDM like that.
Good reason to get rid of MSCS clusters.
Okay, I think it's an acceptable solution.
Hello. 3PAR, could you speak to your work with OpenStack and the Cinder Block project?
Sure. So yeah, we invest in heavily in OpenStack and Cinder. So I don't know if there's any. Don't go away. So I don't know if you had any particular question because we introduced the support for OpenStack and Fiber Channel. We actually were the first one
on
to release
3.13.
that. No, it was back in 2013.
No, the 3PAR OS 3.1.3.
In 3.1.2 MU2 in 2013. So, and what we're doing is that for every new release that we have for OpenStack, we just try and align. And if there's some capabilities that we have in the storage array that are worth exposing to the Cinder driver, I'll give you an example with the release that we had for not Havana, Icehouse, for the outside release where we exposed all the quality of service properties. And we're going to do the exact same thing also when it comes to flash cache for the K release that is coming in 2015. So every time we've got an opportunity to integrate further with Cinder and with OpenStack by just exposing some of our data services, we're just going to do that.
Sounds good.
Okay, did that answer your question? Was that?
Yeah, it's
Okay.
just in generic speaking, trying to get my cinder block versus VVol hat on.
Yeah, I think they're very different use cases, but I can see where in some cases you may want to choose one solution versus the other solution. But when it comes to all exposing, let's say the storage capabilities and so on, we're going to do that also with OpenStack.
Great.
And
Glad
again,
to
if
hear
you were at this morning's keynote, you'll notice that the theme is not or, but and. And vSphere will certainly give you options for integrating with OpenStack, even if your virtual disks are VVols. So no need to choose.
Yeah, that was a good point.
What are going to be the scalability limits for VVols, specifically regarding, so in 5.5 and previous, obviously we have limitations with the number of LUNs per host, and also with VMFS heap size. Is the idea that you can basically have VVols and basically, I guess, avoid that heap size limitation, or it's going to be a limit to VVols per cluster?
So the two limits you mentioned are very separate. The protocol endpoint that I mentioned in the architecture overview counts as one device in vSphere. So you could have up to 256 protocol endpoints. Now, different arrays will export different protocol endpoints for different reasons, and there could be 1, 2, 4, or whatever. But typically it will be far less than the number of individual LUNs that will be exported. So you would expect to be able to scale to a higher limit there, but that depends very much on the exact usage characteristics too. And since there is no VMFS anywhere, this is not a file created on a VMFS file system, the VMFS limitations really don't apply. They're just out of the picture. And you should think of a VVol much more the way you would an RDM, which can map a device of any size.
Sure. No, I was just wondering, is there, so on VMFS we have the heap size limitation, and then on NFS there's, I'm not going to remember what it is off the top of my head, but there's another limitation we have there. I'm just wondering, is there a scalability limit to the number of VVols inside of a single cluster?
The VVols are limited more by the number that you can have bound at any one time, because I didn't want to get too much in the details, and there is a session specifically with a deep dive on VVols that you should probably go to. But when a VM is powered on, a connection is made specifically to that virtual volume, and that's assigned a secondary LUN ID for that brief period that the VM is on. And when the VM is powered off again, that goes away entirely. And so that connection can represent any size virtual volume for that duration. Okay. So, and that limitation is, I think, something like 2 to the 20th bound at once, or 2 to the 40th bound at once, or something like that. So practically speaking, it's not a serious limitation on the number of objects.
Okay, thank you.
Is there a limitation to the number of VVols on an array? Can you set up multiple ones if you have different criteria you need for different virtual machines? Like you want to set up...
So that's going to be a limitation that's entirely array specific. I mean, as I said earlier, the VVol technology by itself doesn't really impose any limitations along those lines. I don't know what the specific limitations are of the 3-par arrays.
So then that will be bound to the limit of objects that we have on the array, but we've been working on increasing them tenfold, just because now we're not talking about our one data store and maybe 50 virtual machines. We're talking about 50 virtual machines, multiplied by 4 or by 8, depending on how many data volumes you have. So we had to work on increasing all the base objects, all the snapshots, and all those limits. And all of those are already in the current release and in the future release of the 3-par OS.
And are you allowed to, is there any limitation on exposing RDMs along with VVols from the same array, or are you able to do that?
It's technically, there's no limitation on it. You can
Okay,
export
so it
regular
just goes
data
off of
LUNs, you can
L1.
export RDMs, and you can export PEs that in turn are used by VVols.
All right,
So you can do that.
all right, thank you.
If you have a question, can
do have
you
a
please
question.
come over to the microphone? Thank you.
So when can we expect to see a release, both on the Unserv side and on the VMware side? And then are you going to offer any guidance on migration and best practices going from, RDMs and data stores to VVols?
Well, the question about a release date for this technology was covered in the legal disclaimer slide.
It's just ... right?
But as far as migration, this is exceptionally great because you can migrate a live running VM from whatever storage is currently running on into a set of VVols using the regular vSphere storage migration without taking the VM down at all. So you can wheel in VVol capable storage and just migrate right over to it.
So I think Pat already said this morning he's going to come out with VVols will be out with vSphere 6, but specifically in the HP or 3-part products, I think you guys are coming out with have your announcements of when they're available. For legacy existing HP 3 stars, to what existing generations will upgrades be available on existing
So I can
systems?
answer that question. So the interoperability is always bound to the FreePAR OS and not to a particular hardware version. So when it comes to the current shipping versions that are the 10,000 and 7,000, they are going to, of course, have full support for VVol. And I think we had an announcement where we said the platform is going to be VVol ready. And that's also on the timeline where I couldn't put a date there because I love VMware. And but when it comes to older, platforms like the T classes and the F classes, we're going to have interoperability, meaning that we will support vSphere 6, but we may not be able to support the VVols, the new VVols paradigm, because there's that explosion of learns and so on that we can't do. So all current shipping products, our plan is to fully support VVols on them.
And so just to be clear, regardless of when you have an array that's VVol capable, you would obviously need a VVol support in vSphere to be able to exploit that.
Of course, thank you.
And for details, I refer you back to slide 2.
Yeah, I have two questions. One is, since this protocol endpoint has this demultiplexing, is there a performance impact you can think in general in the IO speed? And my second question is, as you said, like schedule reservation is no more required as for the VVol architecture. What about the existing softwares? Like one is this MSCS cluster, there is Oracle Rack and other things. Is there will be any support for that or not?
So I think that I didn't fully understand the first question. The second question was more around application support. So, since there was a question around SCSI-free reservations and so on, I still think they're going to continue to exist because somehow you need to tell the block storage that LUN is reserved, right? Mm-hmm. So maybe it's not happening anymore at the VMFS layer, but...
Well, I think what may answer your question is to know that all of the regular vSphere APIs, all the Vim APIs, and the VADP APIs for backup are going to be supported for VVols. VVols to the other parts of vSphere are going to look exactly as any other virtual disk would in the system. So the snapshot APIs apply to VVols just as they do for everything else. VADP applies to VVols just as it does for everything else. So APIs at that level are fully supported and don't have to be aware of VVols. Now, I didn't hear your first question exactly. Maybe we can catch up afterwards.
Yeah, the first question is like, since there is protocol endpoint and there is a IO demultiplexing happening, right? So is there any performance problem or enhancement? What do you think? Like, will that be same as usual or there will be any difference?
Questions about detailed performance are entirely dependent on the implementation on the array side, and that's why questions of how many PEs a given array might export might vary widely among different architectures. One last question?
Just one last question, yeah.
I think the biggest challenge here is with Vivo, it's the scalability. The amount of volumes that storage provider need to export. You're talking that the end target is supposed to be millions, but you're thinking about at the beginning it could be tens of thousands. I know that most storage providers don't have this ability. So 2 questions. 3-part, like for you, how many are you going to support for the first release, or what do you think? How many do you think you can support in the future? And how can you, and for you, it's how can you solve this problem with the other storage providers?
So I'll answer the storage question. So really, what we looked at is, despite the fact that you may have 19 million, amount of VVols, that's I think what is in the spec, if I remember from the top of my head. At the end of the day, we've looked at how many virtual machines do customers deploy on an array today, right? You look at how many virtual machines they deploy, and you look at how much storage is actually allocating. And then you just say, okay, what is the worst case scenario? My worst case scenario is that per every VMDK, I have 8 volumes, and I take a snapshot, and I retain that snapshot for 8 days, or 7 days, or 30 days. Then we just did the maths, and you say, yes, we're going to be able to support the majority of the use cases, and we're talking about deployments where we have 5,000, 6,000 virtual machines today. That I think it's a big deployment. So our numbers will be able to satisfy those kind of big use cases. When we're looking at deployments where you have 600, like Allianz and so on, that's not going to be a problem at all. And then, of course, we're going to look into increasing it until we don't hit a hardware boundary. So if I don't have enough control cache, if I don't have enough cache to handle all of these objects, then of course that will be the boundary of the platform.
So it means that for the worst case, you're going to support 60,000, 70,000 volumes?
That is correct, yes.
I saw a slide on SRM integration with VVols. Just would like to understand, is it what sort of benefit are we getting with SRM for both vSphere application and the array-based application with VVols?
That's vSphere.
Yeah, I'm not sure I heard quite that the question completely. The integration with SRM is not planned for the next release. That's for a later release. But we do intend to support vSphere replication completely on virtual volumes, as I said, just on all the other volumes.
Okay. But I saw a slide on the where it says it allows some flexibility in terms of the SRM. That's why the question popped up in my mind.
That must have been forward-looking. It's not planned for the first release.
Oh, it's not planned. Okay. Thank you.
Okay. Thank you so much, guys. Thank you.